All right, so we're going to be talking about writing equations of parallel and perpendicular lines. Does anybody know, what does it mean if two lines are parallel? Joe?
They're standing up and down.
Okay, they could both be like vertical. That's an example of parallel. Yep. Right, they never touch each other. They don't cross. So we're going to look at lines today that don't cross each other. And can someone remind us again, we already wrote this yesterday, we're just going to write it again. What is the other form of the equation of a line called? Not slope-intercept. That's y equals mx plus b. Does anyone remember the name of the other one? Yeah? Point slope. And does anybody remember what the formula is for point slope? Yep.
Y minus y equals m parentheses x plus.
Yep, exactly. So I think you guys already have point slope form written down above the box. You just want to write down what's in the box. Same formula we did yesterday. Nothing new. And can somebody else remind me, what are the three things we have to replace when we write the final answer? Two of them stay, but three of them have to be changed to numbers. Yep?
Y1, and X1.
Yep. Those are the three things that have to be changed. The x1 and the y1 is a coordinate that they'll give you in the problem, and the m is the slope. Yes? Yeah, can you just wait for Brady to come back? Now, two lines that are parallel, right? They might look like something like this. Can anybody tell me what's the same about both those lines? Something we've been talking about all week. Each of these lines has the same something. And this is what makes them parallel. Yep?
Spacing.
Okay, so they always have the same space between them because they never cross. But what does that mean they have? What else does that mean? Think about in terms of the things we use to describe lines, something that's very important about a line. Yeah? Well, lines go on forever, so they would be both infinitely long. But what else is the same about them? Okay, well, what's different then about, say, two lines that maybe, I'll draw a little bit better than that. What's different about those two lines? They're going to cross each other because they have different something. Yeah?
Angles.
So we don't really use the word angle when we talk about lines, like when we write the equation of it, but it's something that's in the equation. Yeah? No? Yeah?
Slope.
The slope. What makes two lines parallel is they have the same slope. If the slopes are different, then they're going to cross each other. So that's one of the keys we talk about when we talk about parallel lines. Same slope. Okay, so when we want to write an equation in point-slope form for either parallel or perpendicular problem, today we're going to focus on parallel. We're not going to focus on perpendicular. It's almost the same thing that we've done before, like what we just did in the warm-up and what you guys did for home. So I'm going to give you guys an example, and as we go through the example, I'm going to explain the steps so you can see how to do the step. So for example 1, you guys are going to have to write down the numbers because I don't think you have them. So there's a space for a coordinate, and you want to put 3, 5. And for the equation, where it says y equals, you want to put negative 2/3 x plus 4. Okay, so part 1, you guys already have this on your guided notes. It says plug in to the point-slope form. Now, some of these we're going to go through kind of quick. You don't want to write what's in parentheses. You don't have to because you already wrote it yesterday. But if you weren't here yesterday, you might want to write it down. So remember, y stays as y. After the y, the next thing in the point-slope equation is the minus. After the minus, we put a y1. Does the y1 change, or does it stay the same? Yeah, it changes. You're going to plug in the number after the comma from the coordinate that they give you. And what I'm going to do before we do this whole problem, I'm going to draw what's happening, and I'm going to show you what you're trying to figure out, so you can see a picture of it. After the y1, you just put the equal sign. After the equal sign comes the m. Does the m stay the same, or does the m have to change? Yeah? Right, the m is going to change. Now, what the m changes to is going to depend on what the question asks. If they want to know parallel, we're going to do something. If they want to know perpendicular, we're going to do something a little different. Remember what we said about parallel. If you want to find something that's parallel, you keep the slope the same. You don't do anything to it. So whatever slope that they gave you in the original problem, which is that number right there, we're going to use that exact number. So if it's a question about being parallel, just take the number that's attached to x and use that number. Now, if they're asking for perpendicular, I know I left you a 1 and a 2 there. We'll come back to that. Okay, so if they're asking for parallel, you're going to use the number that's attached to the x. After the m, you put a parenthesis. After the parenthesis comes an x. And remember, x stays as x. We don't change it. After that, we put the minus sign. And then what about x1? Does that change, or does x1 stay the same? Yep, it changes to the number before the comma. Yeah. Yeah. So for x1, you're going to plug in the number before the comma. And then you have your ending parenthesis. Pretty much the same as yesterday. Okay, so what I'm going to do is I'm going to draw example 1. and show you what you're trying to find. And then we'll do the steps I just wrote down. Okay. All right, so let me like this. And let me. Okay, so here's my XY axis. And let me draw the line that they give me first. Y equals negative 2/3 x plus 4. Okay, I just want you to just watch this. 1, 2, 3, 4. So there's my plus 4. And what was the slope? Was it negative 2/3? Okay. So negative is down 2, and then right 3. Down 2, right 3. Down 2, right 3. Okay, and I'm going to just draw a line through those points. Okay, and I know I did it more times than I needed to, but as long as you do it a couple times, you should be able to get a pretty good line. About like that. Okay, so that's the line that they give me in the problem. What they're asking me to do is find another line that is parallel to that one. Now, there's a lot of lines that are parallel to that one. That one's parallel. That one's parallel. That one's parallel. So is that one, that one, that one. There's a bunch of lines that are parallel to the one I drew. But they want a specific one. They want the one that's parallel to that one and passes through the point that they give me. They want the one that passes through the point 3, 5. So they want this one. 1, 2, 3, 1, 2, 3, 4, 5. They want the line that's parallel to that black one and passes through that red dot. So that line is going to look, well, actually I can just go like this. Let me make a copy, and I'll make it red. The line in red is what I'm trying to figure out. They want the formula for that red line. It's parallel to the black one, and it passes through the dot that they said it had to pass through. Okay, so let's see if we can find it. So we're going to fill everything into the formula, and I'm going to do this where you guys, where it says plug into Pointslope Form, you guys have like a lot of blank space over here. You could just write the answer right there. Okay, so let's start with y. Y stays as y. Then we have the minus. What's y1 in this case? Yep. 5. It's the y value for the coordinate that they gave you. Then we put the equals. And then the next thing we need after equals is the m. What's the m in this case? Yep. Negative 2/3. Negative 2/3. Then we need, whoops, I forgot the, no, that's right, actually. Negative 2/3, put the parenthesis, put the x, put the minus, that all stays the same. And the last thing we need after the minus is the x1. What's the number before the comma? Yep. 3. That is the answer. So what I just put a box around right there, that is the formula for that line in red. It's the line that's parallel to the one they gave me, and it will pass through the point 3, 5. So that's what we're doing. Finding a line that's parallel and it has to go through a certain spot. Okay. Any question on that one? Yeah.
Why did the 4 in the original equations here?
Well, the 4, that's just part of the line they gave me. So when I draw the line they gave me, it told me to go up 4 and put a dot. That's the only thing you would use the 4 for. And in this problem, you don't have to draw it. The only reason I drew it is to kind of show you what we were actually trying to find. So we were trying to find the formula for the red line. And this is the formula for the red line right there. So you don't actually have to plug this 4 in for anything when you do the problem. Just the coordinate and the slope. So now, sometimes what they might ask you to do is then change the answer that you just got into slope intercept. Okay, that's point slope. Does anybody remember the first step we would do on the right side to change that into slope intercept? Yep. Yep, we would distribute. And for people that were here yesterday, that you guys have already done this. So to change to point slope form, I think you have an extra bullet maybe on your page. You might not need all 3. So the first step is to distribute. So let's write down y minus 5. I'm just copying it down so I can remember what it was. Negative 2/3 x minus 3. All right, let's do that here. Let's distribute. Because I have a fraction, I'm going to use my calculator. That makes it easier. What's negative 2/3 times x? We can't really do much with that, yeah? It's just negative 2/3 x. And now I'm going to type in negative 2/3 times negative 3. And I get 2. Now, is this y equals mx plus b after I do the distribute? What do you think, Matt? No, what do I still have to do? Yeah, I still have to add or subtract the number with the y to the other side. So I think you really only needed 2 bullets under part 2, but you had 3. So you got a little bit extra space. And can anyone tell me, in this one, would we add or would we subtract to move that 5? Negative 5. Yeah? Yeah, we would add. And we would add. So now the y is by itself on the left. Does anything happen to this negative 2/3 when I add 5? No, that just stays the same. And what's 2 plus 5? Yeah? 7. So, if I did a good job sketching this problem on the other page, it should look like my line crosses the y-axis. That's 7. And if it does, then I know I did this right. Now, normally you wouldn't be able to check that because you're not going to be drawing it out by hand. But I did this time, so we can check it and we can see. So let's see if it crosses the y-axis at positive 7. I'll give you guys a second to copy that. All right, so let's look at that line in red, and I'll try to zoom in a little bit. Where does it look like the line in red crosses the y-axis? At what number? Yeah, 7. 1, 2, 3, 4, 5, 6, 7. So yeah, we did the problem perfect. We found the line that passed through the point that they wanted, and it is parallel to the one we studied. Yes. Yep. Just sign out. If anyone still need to copy those 2 steps, distribute, and then the add or subtract. And we're gonna do more of this. This problem didn't specifically, I don't think it asked us in part 2 to actually do the problem we did in part 1, but I'm just showing you the 2 steps, the distribute and then the add or subtract. Okay, so let's try this. This is on the back, so we're done with the front. And it says, do now. Write an equation of a line that passes through the point that they give you, and it has to be parallel to the line that they give you. I'm not going to draw it this time. We're not going to draw anything. Okay, Natalie, can you just remind me, without any numbers, what's the formula that we're going to plug into?
Y minus 1.
Yep. Perfect. Now remember, this plus 1 at the end has nothing to do with the number we're going to plug in. That plus 1 is just there to help you if you wanted to draw the original problem. But this doesn't say you have to draw anything. So there's only one number we need to focus on in that red box. What's the important number that we need to use from that red box in our equation? Yep.
4x.
So what number? You said something with a left.
Oh, 1?
No, the 1 is the number you don't want to use. Yep.
Negative 4x?
No, not quite. Yep.
Negative 4.
-4. The m is the number that's in front of the x, right here. Just the m. Just what I put the box around. So let's write that down. So m is going to be the -4. You do not need the +1. Doesn't. In fact, if that was a +6, it wouldn't change how we do this problem at all. So we need the m. And what about the -5? What's that going to be? Okay. What's the -5?
X.
X
1.
1. And what about the -4? Yep. Y1. So those are the three things that you need from what they give you. X1, Y1, and M. Now just fill them in. So we're going to have y minus minus 4. Remember, minus a minus becomes a plus. Tirza, what's M in this case? Negative 4. We get that from the number in front of the X. And how about Joe, what's X1?
Negative 5.
Yeah, good. Negative 5. And remember, again, we have X minus negative 5. So that becomes a plus. And it didn't say anything in this problem about changing it to point slope form. So you don't have to do the distributive property or subtract the 4. So I'm going to leave it just like that. Any question on that one? Okay. I'm going to go back to that picture I drew for a second. What kinds of lines are these again? They're parallel because they have the same what? Same slope. Now, let me go like this. Are those lines parallel? What are they now? They're not parallel anymore because they're, yeah? No, perpendicular would be when they cross at like 90-degree angle. So those aren't perpendicular. But they're not parallel because they're, what are they? Yep. They're just one line. They're the same line. So yes, both of these lines have the same slope. But when they're right on top of each other, that's like a special case. Even though the slope is the same for the red and the black, those are not parallel anymore. The y-intercepts have to be different. So as long as the slopes are the same, but they cross the y-axis at different spots, then they're parallel. If they cross the y-axis at the same spot, that's just called the same line. That's not parallel. And I think that's the next thing on your guided notes. So equations of lines that have slopes that are, what do the slopes have to be for parallel? Same. So the slopes have to be the same. And we just said that where they cross the y-axis has to be yeah. It has to be in a different spot. If they have the same slope and cross in the same spot, then they're the same line. That's not parallel. So they have to have the same slope, but cross the y-axis in different spots. And we call that parallel. So those are the 3 blanks that you need to fill in on your guided notes. Same, different, parallel. Now, the last thing we're going to do is going to go back to using the formula we've used Monday and Tuesday. Can someone remind me one more time, what's the formula to find the slope if you can't count? It's a fraction, and something goes in the top, something goes in the bottom. Yep?
Y2 minus Y1.
Yep.
And on the bottom is X2 minus X.
Perfect. So there's a spot to write that on your guided notes. Nothing new. I've been using that every day. But just a reminder, because we're going to need that in the next problem. Okay. Does everybody have the formula? Okay. So the question here says determine which of the following lines are parallel. For this one, I don't want you to worry about the y-intercept. All I want you to do is focus on the slope. Because what has to happen with the slope if two lines are parallel? Yeah? The slope has to be the same. So what I need to do is find the slope of line A, line B, and line C, and see if any of the slopes come out the same. That's all you have to do. You have to check the slope. So we'll have line A, something minus something, and something minus something. All right, so just to remember what your formula is, can somebody tell me, don't worry about B and C. Don't even, you can copy them down if you want, but we're not even using them yet. What's y2 for line A? Yep. Yep, -2. I'm just going to check them off as we do them. So -2. What's y1 for line A? Dorian?
3.
Yep. Looks good to me. What's x2 for line A? Yeah. -3. Looks good. And what's x1 for line A? Yep. Good. So let's simplify that, and then we will know the slope of our first one. -2 minus 3 is -5. What's -3 minus -1? Now? -2. Yep. Comes -3 plus 1, which is -2. And the negatives cancel. So the slope of line A is 5/2. If B is parallel to it, what does the slope of B have to come out to? If it's going to be parallel to A. Yeah? It has to be 5/2. Well, we don't know what it is yet, but we will in a minute. So let's do line B. Okay, let's look at line B. What is y2 for line B? Dorian? -2. And Emily, what's y1 for line B? 2. Okay, get that one. Sophie, what's x2?
4.
We're looking at line B. So you should be looking right there. That's x1. That's my first x, so -1. And Tirza, what's x1? 1. All right, let's see what we get. I don't think this is looking good to be the same. -2 minus 2. Well, that's -4. And -1 minus 1 is -2. What's -4 divided by -2? Yep. Positive. Yep. So are lines A and B parallel? Definitely not. Well, we still have line C, and if it comes out to either one of those numbers, then it's parallel. Right, let's check line C. Okay, so we've got over. So line C, y2 is -2. y1 is 2. x2 is also 2. and x1 is 4. Right. Okay, let's see what happens. -2 minus 2. Well, that's -4. And what's 2 take away 4? Yeah, -2. And -4 divided by -2 is 2. So, which out of lines A, B, and C, which ones are parallel? Yeah. Yeah. So what you would just do is write down B and C are parallel. And it said determine which lines, if any. So we might have had none that were parallel. But in this case, we got B and C to be parallel because they have the same slope. Okay, any question on that one? Example 4 is exactly the same type of example. So I'm not going to go through finding the slope 3 separate times again. So we'll skip that one. And let's look at the last one. So reminder, you don't have to write this down because you already put it on Monday's notes. What is slope-intercept form? Yeah? Y equals mx plus b. And what letter there represents the slope? Yeah? The M. So if we want to know if something is written like that and it's parallel, like let's say I gave you these two things. I may ask you the question, are those two lines parallel? You have to look at two things. First, you have to check the slopes. What do the slopes have to be if those lines are going to be parallel? Yeah, they have to be the same. So where it says we look at two things, step 1 is make sure it's in y equals mx plus b. And step 2 is to check what Sean just told us. Make sure the number with x is the same. In this case, they're both 3. But you also have to make sure the number with b is different. Because if this was a plus 6 and this was a plus 6, that's not parallel. Then they'd be exactly the same thing. So these two numbers have to be the same. And the two numbers at the end, that's the b, have to be different. So we'll finish up example 5, and then that'll be the last thing we do. We're not going to do 6. We might do 6 as like a warm-up tomorrow. Okay, so look at example 5. Out of lines A, B, and C, as you write them down, can anybody tell me which one is correctly in y equals mx plus b form? There's only one of them. Yep.
Line B.
Line B. So line B is the only one there that's really good. The other ones we need to fix. So line A is y equals y minus 4x equals 5. How could I fix line A so the y is by itself? What would I have to add to both sides? Yeah? 4x. So let's fix that one. And now it's y equals 4x plus 5. So there's your line A. Line B is fine. And let's fix line C. y minus 4x equals 4. What would I have to add to both sides to fix line C? Yeah? 4x. So that's gone. And I get y equals 4x plus 4. And that is line B. So now look at lines A, oh no, line C. Sorry. Look at lines A, B, and C. Do you see any two that are parallel? I'll copy B down so you can see it with the other ones. Y equals 5x plus 6. That's B. So look at A, B, and C. Are there any that are parallel? Yeah. A and C, I would say yes, because they have the same slope and the y-intercepts are different. Perfect. B, that's on its own. It's not parallel to anything. So A and C are parallel. Okay, so homework for tonight, okay, that is on Schoology. What I'm also going to do is I'm going to pause the video and I will write down a list of topics and the kinds of problems that you should know for the test tomorrow. And I'll put that video online probably in about 5 minutes.
Yes,